All right, a brief summary recap of the entire unit in one page. So first thing we did was roles in MVT. So a little table to compare their conditions and their conclusions. Continuous on the closed, differentiable on the open. And then what makes roles different than MVT is that those endpoints, the y values of the endpoints, have to be the same. And if you're going to use roles, or MVT, you have to show that these three things are true, that they work. Differentiable, the only thing you're worried about there, because if it's continuous, that knocks out some of the problems. But differentiable has a cusp, right? Well, that'd be not differentiable. That's about the only way that it's continuous but not differentiable. And if that is true, if those three things are true, let's see, that's our picture, where our starting and endpoints have the same height, then somewhere the slope equals 0. Maybe more than one somewhere, but at least one place the slope equals 0, and your job, your task, usually is to find C. Like where does that happen? And remember, it's got to be on A to B. So sometimes you got to throw out an answer or two if they're not in the interval that you were talking about. MVT. Well, any questions on that? I want to go quick, but I don't want to zoom past any questions. MVT is a little more generic, a little more broad. As long as it's continuous on the closed and differentiable on the open. So the starting and ending points don't have to be the same. Our conclusion in words is that the calculus slope equals the algebra slope. The instant rate of change equals the average rate of change. The instant rate of change, or the calculus rate of change, would be f prime at c. The algebra rate of change, well, the easiest way to write it would just be y2 minus y1 over x2 minus x1. Right, there's the algebra slope. And somewhere, maybe more than one somewhere, the calculus slopes equals the algebra slope, and your job, just like roles, is to find where that happens. Questions on MVT or roles? Similarities, differences? Right, first derivative. So everything before this unit was like how to take a first derivative, all the rules about power rule and product rule and quotient rule and all the trig rules, and logs and exponent rules. All of those were like process rules. How do I find it? This unit is more like, well, what does it mean? Now that I've got it, f prime or y prime or dy dx all mean the same thing. Well, it would tell me the slope of f. That which in turn tells me where f is increasing and decreasing. I can use it to find relative extrema. It can help me find tangent lines. It can help me find critical points. all of that comes from first derivative. And usually first derivative, set it equal to 0, and then depends on what the problem asks for, what you do from there. The specific thing that we'll ask for is the first derivative test. That was if f prime changes signs, then f has a relative extrema. Right, that's the number line thing, where you draw out the number line, and a lot of times we even sketch the increasing and decreasing thing, and if f prime changes, then you either got a max or a min, and you don't memorize which change is what, you just look at the picture or think about it, increasing to decreasing, f prime positive to negative would be a max. When we say justify a relative extrema, the answer is always going to be f prime changed from positive to negative or negative to positive, depending on which extrema we've got. Right, then we talked about the second derivative. F double prime or y double prime or d squared y over dx squared. You got to be careful how you write that one. That tells us concavity, which sort of leads to inflection points, where concavity changes, positive to negative, negative to positive. That tells us if f prime is increasing or decreasing. What? I should have... Up here on the first derivative group of things, f prime tells us if f is increasing or decreasing. F double prime can tell us if f prime is increasing or decreasing. Or vice versa is usually how it's used, because we'll have a graph of f prime. If f prime is increasing, that means it's concave up. The second derivative test for max and mins, again, which seems a little bit weird because usually second derivative is for concavity, first derivative is for max and mins. But the second derivative test for max and mins, it has a little bit of first derivative in it. If f prime equals 0, then two options. If f double prime is greater than 0, then, again, this is not one that you memorize, you just think about. So think about the picture, or what it means, where f prime is 0 and f double prime is greater than 0. So do we have a relative max or a relative min for this case? Min, because a concave up, a relative min. Again, I don't have that memorized. You think about what's going on. It's concave up, but there's a horizontal tangent line, so the only way that works is if it's a relative min. And then the other one, if f prime is less than 0, so it's concave down, but it has a horizontal tangent line, then we've got a relative max. For most of the problems, I'm going to do that little flowchart thing again. We find critical points first. F prime is 0 or undefined. That tells us the possible extrema. And then we have those three options. A table will tell us the absolute extrema. Right, we're just looking for the biggest value. Remember, the table has to include the possible extrema and the endpoints. Table with endpoints. We can do the first derivative test. That's the number line with intervals, increasing, decreasing, that sort of stuff. That gives us the relative extrema. And then the third option was the second derivative test. You evaluate the second derivative at the critical points. That also tells us relative extrema. So again, there's a whole bunch of questions that are, covered in that one little flow chart there. Questions on anything so far? And then lastly, we did a little bit of, we didn't call it this, but we did this, combining f prime and f double prime effects for graphs. Table and summarize. So we could have f prime being positive or negative. We could have f double prime being positive or negative. I want to draw a little piece of a graph in each of those quadrants. So if f prime is positive, that means we're increasing. If f double prime is positive, that means we're concave up. So a little piece of a graph that's increasing but bold up looks something like that. We did a couple of these on a worksheet, sketching in pieces. If f prime is positive, increasing. If f prime is negative, concave down. So I need to draw a little piece that's increasing but concave down. So increasing but bold down. Something like that. If f prime is negative, that means f is decreasing. If double prime is positive, that means we're concave up. So decreasing but bold up. So going down but bold up. So something like that. And then lastly, if f prime is negative, f is decreasing. If f double prime is negative, then we're concave down. So I need to be going down, decreasing, but also bold down. So something like that. Again, the hope is you don't have that table memorized. The hope is you understand what's going on. And when I ask you a question about graphing and give you some specifications, you could piece together what a graph might look like. All right. Obviously, there's a whole lot more detail in all of that stuff, but that's a pretty decent overview of what's in this unit. Let's get a little more specific and talk about what's on the test, especially which day, so you can maybe focus your studies. Wednesday is free response. There's one multiple choice just because the spacing of the test didn't work to put it all one way or the other. By the way, the entire test is no calculator. It kind of makes sense because there hasn't been a whole lot of numbers in this unit. It's more about the concept of increasing, decreasing, concave up, concave down. So don't need a calculator. It also means the roles in MVT stuff is pretty straightforward algebra. So we could ask maximum and minimum from a graph. Right, give you a picture and ask for the max and min. What we're really worried about there is the open circle, closed circle business. So on that picture that I just drew, which absolute extrema does it not have a minimum? Because there's an open circle there. You couldn't say what value that gets to. We specifically ask you to use the first derivative test to find a max and a min. So you remember that's where you do a f prime number line. F is increasing, decreasing, increasing. So there's a max and a min, that kind of stuff. We'll also ask you to use the second derivative test to find a max and a min. So you have to be careful on those two. I guess I'd give you some points if you got the answer using the wrong test, but I'll be looking to see which, did you use the right test? Oops. Second derivative would be the concave up, concave down. That tells me if I've got a min or a max, that kind of thing. A roles problem, an MVT problem, and a sketch graph from info problem. Meaning, I'll give you information about f prime and f double prime and ask you to sketch a picture. And that's one where everyone's picture might be slightly different, but that's where we'll be looking for, well, concave up, but increasing, concave down but increasing, that sort of stuff. That's the Wednesday test. The Thursday part is mostly multiple choice questions plus one free response question. Again, I couldn't make it all multiple choice and all free response without using up too much paper, so we'll rearrange things but then tell you where things go. On the multiple choice, it was almost all from this unit. I didn't see a whole lot of review stuff on there. So it's all the words we've already said. Increasing, decreasing, max and min. Be careful about relative versus absolute. Critical points. Point of inflection. There's an MVT problem thrown in the multiple choice. So obviously it's not the full piece of it. It's like one piece of it. Extrema, although I guess that's the same thing as relative and absolute max and min. So all that first to second derivative concept stuff. And then what you really need to know is that the free response question is, given a graph of f prime, find all sorts of stuff. But we've seen a couple of those. Where is f increasing or decreasing? Where does f have a max or a min? Where is f concave up and concave down? Those type questions. So now you got a pretty good idea of what's on the test and which day it's on. We still have time left for me to answer questions on whatever you got on those worksheets.